Well, let's go ahead and start. Let me share my screen first. This is Chapter 13, Configuring Network Services. Our objectives: configure infrastructure network services including DHCP, DNS, NTP, and NIS. Configure web services using Apache Web Server. Configure file sharing services including Samba, NFS, and FTP. Configure email services using Postfix, and configure database services using PostgreSQL. I'm saying that correctly. Now, infrastructure services. These provide network configuration support for other computers on a network. And these include DHCP, DNS, NTP, and NIS. DHCP stands for Dynamic Host Configuration Protocol, and this is used for automatically configuring a network interface. The client sends a broadcast on network asking for the IP configuration information. The server, DHCP server, leases an IP address to the client computers for a period of time. So it doesn't give them an IP address for all eternity, so they expire. This ensures each client has a unique IP address, because if you have two clients that have the same IP address, then you have conflicts that will exist. And then after expiration, client must send another DHCP request. You can actually expire, in a lot of cases, you can expire this yourself and request a new one. Now, the process involves client sends a request to all hosts on the network. In reply, DHCP server sends an offer containing potential IP configuration. The client accepts it. DHCP server sends acknowledgement indicating the amount of time client can use IP configuration. And the client configures itself with the IP configuration. And here's the client over here. So this might be your desktop maybe. Then we got our server on this side. So sends a request over saying, hey, I need an IP address. So we got DHCP Discover here, and it sends an offer. Say, okay, here's an IP address. So over here it says, okay, that's fine. I want that. Sends it over here, and then the acknowledgement is sent back with the expiration information. Now, the DHCP lease process on a Linux system. You need to configure a Linux system as a DHCP server. You need to install a DHCP daemon, and this is available from online software repositories. The most two common ones are DHCPD, DHCP daemon, BusyBox, DHCP daemon, UDHCPD. UDHCPD. Say that 5 times real fast. Okay, now configuring a Linux DHCP server using DHCPD. To configure a Fedora 20 system, you add a DHCPD user account to be used by the DHCPD. You edit the DHCP daemon configuration file to list the appropriate IP address range for the network and lease information. And you see the two different configuration files for storing IP version 4 and IP version 6. So again, it's just not any IP address. You actually are specifying. what to use. And then you start it. And you also configure to start a boot time, because that's not something you want to start manually each time. You want, if the computer, the server gets rebooted, then you want it to automatically start up. Now, using udhcpd, some Linux systems, including Ubuntu Server 14.04, use the udhcpd daemon. And to configure that, you change the DHCP enable to no within the udhcpd file. You set dhcpd enabled, yes, save changes, and specify the appropriate IP address range and other IP configuration information within that configuration file. And then you start it. And again, you configure it to start a boot time. So it's more than just starting it, but you want to automatically start up. Now, just before we go on, how to expire the IP address in Windows 10. See how there's a IP config, this is in Windows 10, of course, IP config / release and IP config / renew. Sometimes things just get haywire with your current configuration, and you need to do this release and renew. And you'd use appropriate commands on Linux to do the same thing. You know, I don't think I've done that forever. It's probably been 20 years since I've had to actually get a new IP address. Typically, the process is pretty seamless behind the scenes. You don't even know it's occurring from the client side, if it's configured correctly on the network. DNS, a hierarchical namespace used to identify computers on large TCP/IP networks. You have a zone, and we've already talked about what DNS is before. Zone, portion of the DNS administered by one or more DNS servers. And we got a forward lookup, FQDN resolved IP address, and reverse lookup IP address resolved to FQDN. And I'm just going to show it on Windows here. Ping cali.edu. Okay. That's interesting. It's actually coming back today. That's what it's supposed to do when it times out. Exactly what it's supposed to do. I don't know why that hadn't been working. So the ping is not going through, but that's okay. I just wanted the IP address. And remember, we can come here. You can type 174, 143, 127, 206, which is Cali. And we'll find Cali's webpage. Now, having that information is useful, that IP address, because if for some reason people can't get to cali.edu, what you can do is you can type in that number and see if you can get there. If you can type in a number and get there, then that means that there's something askew with the naming. It's the connection between cali.edu and that IP address. So DNS might be messed up. I don't know if I can find a reverse lookup. Used to be able to find these pretty easy. Reverse IP address. Okay. So it looks like it might be. What is my IP? Okay, so reverse DNS lookup, 174.143. Not sure what that reverse email address lookup is right there, but 127.206. And you click lookup, and notice what it gives us. It gives us this right here. This must be who is hosting our site, I'm guessing. Now, realize that if I put in 10.190.40.54, this is the printer in my classroom here. And if I press enter, see, it doesn't really come back with anything. IP addresses that are local to your network, that's not something you can look up in these databases here. This DNS lookup is for the things that are external to your company. So if you set up a server with its own IP address so everybody in the world can see it, for example, that'd be kind of bad if everybody in the world could print to my printer. Probably receive already. I receive even printouts that come out from people who don't know where they're printing to. Received 2 or 3 of them yesterday. I haven't even looked at yet. Okay. Yeah, I'm just really not putting the right keywords in this morning. I don't know if I can put in a address here or not. Or I have to put in cali.edu. From I'm not a robot. No, I'm not a robot. Oh, I hate these. My eyes aren't good enough to actually identify the ones that are the whatever they're asking for. Hopefully that's all the buses. So that's not supported. Traffic lights. There's a traffic light. I think that's it. Obviously not. Select all scores of crosswalk. That little tip there be a crosswalk? Let's say it is. And it's interesting. This is all blank up here. We must be paying for privacy. Kind of unusual for a company, but not unheard of. But then again, it's all down here. Huh. I don't know. Anyway, this is a way you can look up your domain name and find out where the name servers are pointing to. Nothing there. I was wondering what it would come up with. So again, another tool to help you figure out more information about your site. So in some cases, you can put in an IP address and you get the website name back. Sometimes you put in a website name and get the IP address. Now, the way the DNS lookup works, when contacting a web server using a web browser, the web browser performs a forward lookup of the FQDN to contact the IP address of the web server. Forward lookup is performed by DNS servers. So we got cali.edu. Well, how do we know where to go? Cali.edu, what state's that in? What country's that in? Again, it's not that kind of lookup. So it needs to go out there and get what the IP address is. And even more than that, just not the IP address, but some information about a pathway to take. Iterative query resolved using DNS cache does not use top-level DNS servers. The DNS database can be local to your network, can be on your ISP, or it could be up at the top level. Because if you got a site that a lot of the people at your company are going to, it doesn't want to keep going up to the highest level to get that IP address. So that should be stored locally. Recursive query resolve with the use of top-level DNS servers. Here's DNS Lookup Process. Directive listen 80. Apache daemon will listen for HTTP requests on port 80. Got our server name, server1.class.com, name of the local server. Document root /var/www.html. Document root directory is this for the local computer. Got a directory index, index.html is a document root directory to be sent to clients who request an HTML document. Server root /etc/httpd, all paths listed within this are relative to that directory. Error log, user Apache, group Apache, so forth. All of this kind of works together to achieve that. The Apache, that's your software running on your server that handles the web requests. It handles everything about the web. This document root /var/www.html. This is where it's stored at on that local computer. So when you go to cali.edu, it might be accessing index.html, and that'll be where it's located at. And you configure all this via, although you can probably do it in other areas, you configure some of this via the Apache configuration files. Okay, configuring a Linux DNS server. Configure the DNS name daemon for a specific zone. Add resource records that list FQDNs and associated IP addresses for computers in that zone. There's obviously nothing wrong with hardcode in Kali's IS 174.143.127.206 because for Kali itself, because that's not going to change anytime soon unless we change who our provider is going to be, and they give us a different address. So the configuration files have the bind format. This is difficult to create manually. Use graphic utilities such as the bind configuration utility. Start the DNS name daemon. Then you got your dig command. Use query records that exist on a specific DNS server. And this is talking about your common zone configuration files. And I'm not going to sit there and read all that to you. This is all in the ebook, so you can read that. More about the zone configuration files. Here's the bind configuration utility they were talking about. So you see it's a GUI, which is good. Or at least you can use a GUI, I should say. Network Time Protocol, NTP, used by the operating system to obtain time information, BIOS system clock, or from network servers. HW clock command modifies BIOS date and time. uses UDP port 123, and two NTP daemons commonly used on Linux systems is NTP daemon and NTPD and cronny, if I'm saying that right. NTP daemon, cronny D. Network time protocol, obtain time information. We're going to talk more about that. Okay, understanding NTP Strata. Strata is a hierarchical series of time resources used by NTP. Stratum 0, atomic clock or GPS clock. Stratum 1, obtain time directly from Stratum 0 device. Stratum 2, obtain time directly from Stratum 1 device. Stratum is not an indication of quality or reliability. NTP servers obtain time information from multiple sources and use algorithms to determine the most reliable time information. This gives you an example where you got an atomic clock here, and then you got that's Stratum 0, the Stratum 1, and then that's going out here to these to Stratum 2. Why even really mention this too much? Why does it matter? If you're just working and saving documents, probably not that critical. If, on the other hand, you have people logging into your system, and they're logging your system to sign themselves in, that becomes a lot more important. If I'm going to fire somebody for being late 2 times, my clock better be right. I worked at a place that would fire you if you were late 2 times. At IFR where I worked, it was quite important that our servers have the correct time on it. Not some time that's IFR has decided to use, because the computers can get off in terms of their time. So we had to make sure that we synced it with an atomic clock somewhere. And there's one off the internet that we synced it with. And I don't remember the syncing time that we did, if it was once a day or once a week or what we did exactly. But we made sure it's synced up with that for the very reason I indicated. And that's true in any business. If you got somebody who's going to challenge you for firing them for being late, and your clock is notoriously not right, they're going to win. They'll win their lawsuit. Now, I suppose if you're 5 hours late each day, then they won't. But if we're talking about they're 5 minutes late and you're writing them up for that, then again, larger issue. Now, working with the NTPD, NTP daemon, NTPD, usually installed by default, can act as the NTP client to obtain time from the Internet Time Server or as the NTP server. Again, finding a reliable Internet Time Server is the best. To configure the NTP client, you edit the NTP configuration file to add lines for different NTP servers can be queried. NTP date command manually synchronize the time. So if you do notice it off, you can go ahead and synchronize it. Now, offset is the time difference between the time on the local computer and time on the time server. We always had this issue during daylight savings time, because it would automatically update the time when the time changed. You might say, what's the big deal about that? Well, if you're running a third shift that runs over midnight, you've potentially either given those employees an hour extra time or reduced it by an hour when you shouldn't have. So you got to figure out from a company standpoint, how do you handle that? There's probably no time during the day, assuming you have 3 shifts, when you could update the time and not have it affect somebody. At IFR, if I remember right, they just manually adjusted their base time, which is, again, kind of an issue there. There's some legalities involved. Not so much with that, because you got a acceptable reason why you're adjusting the time. But if you have somebody that's just adjusting time, why are they doing that? Why are you giving somebody an extra hour? Or why are you taking an hour away from them? I never realized there were so many issues with timekeeping until I implemented that system. This is like quite a bit to consider. NTPQ command used to see what actual time servers the system is synchronizing with. Jitter buffer stores the difference between the server time measurements from different NTP servers used by NTP when determining the most reliable time. NTP-P option displays offset and jitter. If you're synchronizing it and the server you're synchronizing with don't agree on time, then that needs to be recorded. By default, the NTP daemon is not configured as an NTP server, and allow other computers to query the NTP daemon. You edit the NTP configuration file, add a line identifying specific computers or networks that are allowed to query it, and then you restart it to get the changes. Now, some modern Linux distributions use cronid, I hope I'm saying that right, in place of ntpd. Offers a faster response time, is backwards compatible with ntpd. And this uses the etc cronny conf file, nearly identical to the ntp conf. Use a cronny c command to provide functionality that the ntp date and ntp commands do with ntpd. Now, NIS, Network Information Service, is used to coordinate common configuration files across several Linux computers. Participating computers belong to an NIS domain and use the NIS map to access configuration information. Now you got an NIS master server that sends all the NIS map configuration to the slave servers. And NIS slave servers distribute maps to NIS clients. You might say, well, why is that necessary? If you look at how many servers Google has, here's an estimate. They're running 900,000 servers. They almost have 1 million servers. So having some kind of technique to provide some kind of functionality across all those servers is important. Not everybody would necessarily need this. Now configuring, I wonder how about the NSA? How many servers does NSA have? Probably won't ever say. No, it doesn't. I assume they have just as many as anybody. There's all the, let's see, Facebook. 60,000 servers. Amazon. 2 million servers. Assuming that's correct. And that's old, 2014. Okay. Not saying that they're Linux servers. Don't know. But you can see there's necessity for having some kind of management tools for that. Okay, configuring an NIS server on a Fedora 20 system. You install the ypserv and RPC bind packages from a software repository. Define the NIS domain name via yp domain name, NIS _domain _name command. In the makefile, edit the list files to be made into maps. If no slave servers, ensure no push equals true. and add identification of allowed clients to the secure nets file. Allow the allowed clients to access appropriate maps in ypserve.conf. Start the ypserve and RPC bind daemons, set them to start at boot time, and generate the configuration files maps by typing the yp init-m at a command prompt. Install the yp bind and RPC bind packages via software repository. Define the NIS domain name. Edit the auth configuration file to read usenis equals yes. In the yp configuration file, add domain nis underscore domain server nis underscore server. Alternatively, add domain nis underscore domain broadcast. Start the yp bind and RPC bind daemons, set them to start boot time. Locate the NIS server by typing yp which command. Edit the NSS or nsswitch.conf file and add the keyword NIS before other methods for user group and hostname lookups. Ensure all users on NIS clients use the yp password command to change the NIS password. Now our web services. Apache is the most common web server for Linux. Started as HTTP daemon. There's IIS for the Windows side. Document root directory stores default HTML content, the entire website for a web server. So that's where you have all your HTML files, the index.html, the services.html. It's where you have your JavaScript, all of that, your images. It redirects it. When it receives a request, it looks in the configuration file and says, okay, here's where my files are stored. Default document is index.html, although you could have index.htm also. What that means is you don't have to spell that out. What's that mean? Go to cali.edu. I'm not telling it what file it'll load here. If I go to missions, you see it says index.html. If I get rid of the index.html and press enter, it still goes to the same site because that's our default one. Over here in Kali, I don't know what our default one is. Let's see if I use right slash. So cali.edu or cali.edu. Try it again. Index.html. It found that. Let's see what index.htm does. Okay, so the default one is index.html. There's other ones. I think I've seen some web servers that had default.html. That's obviously not it. It was index.html because that's what we found. Default HTML files for the server. I'm probably not going to find what I want. Okay, what file loads first? No particular file specified. The default the directory index file will be the first file the server loads from a folder. Okay. If you simply type in example.com, server will load the directory's index file. Server looks for these specific files in the following order. Looks for index.htm first, index.html, and then index.php. Now, it's possible you can change that in a file setting, in a configuration file setting, but by default, that's what it goes off of. Important to keep in mind. So if you have all three in your folder and you're changing one, thinking that's your one's coming up, it may not be. Our HTTPD config default configuration file in Fedora 20, and each line directive, each line within a configuration file. And again, here's the default ones that are in that configuration file. And this is what we had earlier when I was mentioning these are Apache-based items. So you document root, you can point somewhere else, as you see here. Default settings are sufficient for most web servers. You copy the appropriate HTML files into your /var/www.html. And you start Apache by doing your service, HTTPD, and then start. You can have multiple websites on one server. And you can configure that with the Apache file. Separate HTTPD daemon to start each time a client request is received. Called a web page hit. First daemon started as root user, others started as Apache user. And you got your curl command, use the bash shell to obtain a web page. You know, I don't think I've ever used the curl command. That's got me curious. Excuse me. Grab a drink here while it's loading. osboxes.org. Curl. Probably doing something wrong. Guess I still won't know how to use curl. Okay, file sharing. There are many file sharing services available on Linux systems. Most common include Samba, NFS, and FTP. I use FTP quite a bit. It's a way you can transfer files. Samba daemon emulates SMB protocol, formats TCP/IP data like Windows computers. NetBIOS name daemon to create an advertised NetBIOS name for Windows computers to connect to a Linux server. And NMB lookup command tests NetBIOS name resolution in Linux. Create a local Linux user for each Windows user. We got our SMB password command, generates passwords. SMB conf, default Samba configuration file. Edit to include NetBIOS name. Test parameter command, checks the syntax of the SMB conf. If you change the SMB conf, you must restart the Samba and NetBIOS name daemons. That's not unusual, by the way, to have a separate user for each entry into a server like that. That's what FTP does. Test Samba functionality after configuration from Windows client, enter // Samba_server in the run dialog. where the Samba underscore server is your NetBIOS name or IP address of the server. SMB client, used to connect a Linux computer to a Samba server. Can also be used to display an FTP-like interface in Samba or Windows servers. And you see the accessing a Samba server or Windows client. Looks like that. NFS, a network file system, allows Unix, Linux, and Macintosh OS X computers to share files transparently. One computer shares or exports a directory by placing its name in the /etc exports file. The mount command used by another computer to access an exported directory across the network by mounting a remote directory on the local computer. Now, to install a Linux NFS server, you install an NFS server package, create a directory containing information to share, edit the exports file, add a line listing the directory to be shared /options, save your changes to the exports file, and run export fs-a command for an updated list of exported file systems, and then restart the NFS daemon. Connecting to a Linux NFS server, show mount command to see a list of available NFS shared directories on a remote server. To access files using NFS, mount a directory from a remote NFS server to a directory on a local computer, and use the mount command, specifying NFS file system type, server name or IP address, remote directory, and local directory as arguments. And use umount command to dismount remote directory. Again, FTP is what most people use. Protocol most commonly used to transfer files in public networks, host files differently than NFS. In anonymous access, a special directory is available to any user who wants to connect to the FTP server. This is, you see anonymous access a lot less than you used to. Every FTP server used to have an anonymous access. And then people started putting stuff up there they shouldn't. Illegal items, illegal pictures. It's a way they could transfer information to somebody else, inappropriate pictures, underage children or whatever, and nobody will track them, except for there are logs and so forth. But put up their illegal software. Software you've downloaded from some torrent site, Microsoft Office, and share it with everybody. Again, it wasn't good. By having everybody have their own name, then there's some kind of way to track the person and say, okay, well, you put this up here, and and so forth. User can log in via an FTP client program to a home directory on the FTP server. I don't think it's anything real complex there. User can log in. I don't remember my IP address for my website, but I come to File Explorer here, and you type FTP : //FTP dot whatever, like that. And it connects to your FTP. Let me see if I can find some public FTP sites. Maybe I'm wrong about anonymous FTP sites. I know we stopped having that feature ourselves. Okay, let me grab this one here. FTP : Brown University. So come here. Oops, not there. Okay. Public section is public. Okay, go to public. And what do they have out here? Animated texture 2. That looks interesting. These are Linux files. You know, is that a software package that they've uploaded there? I don't know. Let me try to copy a file. Pink Panther. So copy that. Let's see if I have rights here. And I'll paste it. Sure you have permission. Okay, I don't have permission there. So where is their anonymous at, if they have one? It says anonymous FTP. It's for posting software and to the user section is for posting materials meant for a limit on that who may access them. What's the user section? Paste. Nope, still can't. Might be I have to be, it should be a student there. Unless I see a folder is like anonymous. PDF files. Yeah, open it up. So here's a. Is that the one I just opened? Okay, let me copy that, and then I'll paste it over here. By the way, it's not safe to open up PDF files. They can contain viruses, but I'll live on the edge here. ErgoDesk, framework for 2- and 3-dimensional. Okay, blah, blah, blah. Interesting. So again, it's a way of sharing files. It's not specific just to Linux, as you can see. Looks like that's a Linux server where all that's coming from, but I'm on a Windows machine here. Try not to give anonymous access, because I could have sat right there and uploaded an illegal picture that would perhaps have caused them some headaches. Okay. And they say an FTP client program, you can have an FTP client program, or you can simply do it via like File Explorer or other utilities. Brown. ntpd.cs, brown.edu. Not that I can see this, my current resolution, but let's see. Activities. It's so small, I can't even see it. I'm wondering if I haven't yet tried this on the graphical side over here. And I thought I could just type in the bar up there. How about other locations? Huh. I don't remember how to do this. Unless I do a find. FTP : I can't even see that. ftp.cs.brown.edu. Okay, obviously that isn't it. Oh, right down here in our server address. That's nice. Paste. And connect is anonymous, so click connect. There's our same files. Okay. Now there are FTP client programs. Don't get me wrong, that provide a lot more functionality than that. I think I used a WinFTP for quite a while until I thought that File Explorer was robust enough that I didn't need to use WinFTP. I don't even know if it still exists. It's now free, so I think it is. So yeah, that reminds me of what I used to use. I guess not free, but pretty cheap. I don't even remember why I think because it made it so much easier. Change mod button here. So there's a lot of different functionality with it, but I don't even remember why I liked it so well when I was using it. That was about 22 years ago when I was a webmaster. So times change. Let's see. Comment was different than configuring it. Very secure FTP daemon. VS, very secure. FTPD, used by most Linux systems. To configure, assuming logon as user 1. Create a directory below user 1's home directory to host files. Ensure user 1 owns a directory. edit the vs-ftpd conf to modify the appropriate commented options, and then start the vs-ftp daemon and get it going to boot time also. Connecting. Most web browsers have built-in FTP utility. I don't know about that. I have limited success with that. I find it better if I go to File Explorer when I'm on Windows. In theory, I can come up here and type Now, sometimes this will work, and sometimes it won't. Like I get here, and then I'm fine. I can access the files, but then how to upload a file, I really draw a blank, and I have to do some thinking and digging and so forth. Because you can just click this, but for the life of me now, I don't remember how to upload. Not that I have access to their servers. But you can see it's a little bit more user-friendly, maybe, way than File Explorer. Maybe not. But that's what they're talking about. Now, if you got a password on it, this is what you do. FTP://user at or user:/password at server name. Most OSs have command line FTP utilities. Use FTP command, specify hostname as argument. When I update my website, mathheals.com, I do it through FTP. There is a more secure tool available via Network Solutions website, but I don't like it. It's clumsy. I like File Explorer because I can easily transfer files. I can select a whole bunch of folders and copy them to my local computer to back up my website. Or I can copy a bunch of folders on my local computer to my website. It just makes it so easy. By the way, there is, and I'm not very good at this, and I'll probably fumble around and really mess it up. Those are the graphical ways. There is a way to, over here, CS, let's see if I can remember how to do this. That'll be the miracle. FTP CS brown.edu. Install it, yes. Proceed with changes, yes. I've only had to do this maybe once or twice in a production environment, and I fumbled around with it. It was hard because I didn't know the commands. I'm not used to doing FTP from a command prompt. And I thought it came back and told me, maybe not. Okay, help, connect, debug, disconnect, connect. I see a disconnect, so I'm assuming there's a connect somewhere. I'm not seeing it, but well, I don't see a connect. You can see I got great skill at this tool. FTP brown.edu. Hey, I'm connected. 1550 is allowed. Have no clue what I'm doing. Password required. Enter. Login failed. Okay. That's interesting. What do I want? Let me log in as anonymous or something. But anyway, you get the idea. You go in here. I think open. Maybe. I'm already connected. Okay, good to know. Make directory. I probably don't want to make a directory. How to list files? Probably file, maybe? Directory. There's remove directory. dir. dir. You aren't logged in. So if I was logged in, I could go through and fumble around with those commands. You can see why I like the GUI. It's much better. There's only a few times where I've had to do this where I could not use the graphical user interface. Okay. Here's where they're showing it via web browser, like I showed you. Help. This is, I think, what I was doing. Displays a current directory, pwd, dir displays a directory listing, cd, lcd, get downloads the file name to the current directory on the local computer. So if I was able to successfully sign into their FTP server, I could have done a get on the file name and I would have downloaded it. Let me try to find one. List of public FTP servers. List of all open FTP servers in the world. I'm not sure if I trust a lot of these. Stanford. Okay. SESFS. FTP SESFS.Stanford Stanford.edu. If this doesn't let me in, I won't even try. So I could sit here and probably type in 100 FTP sites, and before I find one that doesn't require the password. Connection refused. Okay. I'll forget that then. But you can set up your own FTP site. Way for your employees, way for your students to share files. Why would you need to not use a GUI? Well, if you got a server that you need to get a file to, you need to transfer a file via FTP to, and there's other ways to transfer files, by the way. But if you have a server that you need to access an FTP site to download a file, it may not have a GUI. Here's some more FTP commands, and you can read all those. Open hostname or IP address, quits it. Okay. Email services. Various email protocols exist, include SMTP, ESMTP, POP, and IMAP. An email server looks up the name of a target email server and domains MX records stored on public DNS server. Resolves a target email server name to IP address using public DNS server. Again, if I sent Hayes at cali.edu, cali.edu, it doesn't know where that's at, so it's got to resolve that. It's got to figure out where to send it to. Daemons and system components rely on email to send important information to the root user. Most common email daemon used on modern Linux systems is postfix. configured by default to accept email on TCP port 25 and route to appropriate user. To check email, use the mail command. I don't know if this is set up or not, but let's see. No mail for OS boxes. Guess nobody emailed me. The aliases file contains other email names used to identify different users on the system. That file is edited, run new aliases command in order to rebuild the aliases database. By the way, mail help. Lots of different options you can do here. I'm not very good at this. Mail-r address. david.hayes@cali.edu-s. Get to work. What if I need anything else? T-file. Like I said, I'm not very good at this, so try that. I doubt if it would actually work. That's assuming I put all the required options. We'll let it go off and think. We'll come back and look at it. But it's command line. Well, what's the benefit of that? Well, you can run via script. So you can put into a script, and if something goes wrong, you can have it mail you automatically. Database services. Databases, large files that store information in the form of tables. A table is organized information list. A record is set of information about a particular item within the list. Fields, categories of information within a record. Relational databases, databases in which information within one table is related to information within other tables. Tables are usually linked by a common field, and SQL is the most common way for that. That's here. You got your table up here, and it's got an employee ID. And then this employee ID is also down here, so you can connect two together based upon employee ID. SQL, structured query language, program language used to store and access data in databases. Server programs allow use of SQL, are called SQL servers. They offer advanced backup, repair, replication, and recovery utilities for data, and allow programs to access databases from across the network. PostgreSQL. Why am I having so much trouble with that? PostgreSQL is a powerful SQL server that provides a large number of features. Can be installed via software repositories. I never have worked with this. Prepare for use by use password Postgres command to assign users a password. Modify the PostgreSQL configuration file, PostgreSQL.conf. And start it. Now configure it. Log in as a Postgres user, execute the Postgres SQL command line utilities to create and manage databases, and it can create tables and add records within the utility. Many built-in commands prefixed with a slash. I'd play with this sometime. Here's some more commands. Here's how to configure it. Then our summary. Postgres. I doubt there's any way I can access it. Didn't like this. I must have my command wrong. One more to kill a letter. dead letter. Okay, so that implies I do this and say, Dear David, I wish you would get to work. Then Control C. No. Don't kill this letter. Control D. I went to the dead letter file again. Linux, how to use the mail command. Need to know how to end the message. That didn't tell me anything. Oh, maybe I gotta echo something into it. Okay, maybe that's a key. Echo. Dear David, I wish you would get to work. Pipe. So I pipe it into there. Pipe it into mail -r David Hayes at cali.edu -s get to work. No such file or directory. Okay, send mail may not be configured. Providing this file are Elm. Pine. Pine is, I think, an email client I've used before. Anyway, we're done with that chapter. So we'll go ahead and stop there. I'll stop the recording.